Okay, hello everyone. So today's topic is cells in parallel. So we'll discuss how cells are connected in parallel, how to find their equivalent EMF, how to find equivalent internal resistance, and then we'll also solve some numerical related to this topic. So first we'll move to how to find whether cells are in parallel or not. Okay, see, we have two cells, one of EMF E1, internal resistance R1, another of EMF E2, internal resistance R2, connected like this. If you'll see, the point in front of both the cell is A and the point which is behind both the cells is B. So when points across cells are same, they are said to be connected in parallel. So the cell of EMF E1 and internal resistance R1 and the cell of EMF E2 and internal resistance R2 are connected in parallel. And suppose the current from the first cell is I1, the current from second cell is I2. So I1 and I2 will combine to form I. So from Kirchhoff's current law, I will be equal to I1 plus I2. So this is our first equation. Now we'll find out TPD across first cell. So TPD is basically VBA. So VBA will be minus I1 R1 plus E1, because how to calculate TPD? From behind the cell to front of the cell, you have to move and write Kirchhoff equation. So VBA will be minus I1 R1 plus E1. So I minus I1 R1 will go on that side, VBA will come on this side. So I1 will be equal to E1 by R1 minus VBA by R1. So this is equation number 2. Similarly, remember that when cells are connected in parallel, terminal potential difference across them will be same. So for the below cell also the TPD will be VBA because points across them are same. So VBA will be minus I2R2 plus E2. So I2R2 will be E2 minus VBA. So I2 will be E2 by R2 minus VBA by R2. So this is equation number 3. So we have already calculated I1 and I2. We have already calculated I1 and I2. That is equation number 2 and equation number 3. Now what we'll do is, see, I1 and I2 are written. So I1 plus I2 is basically we are adding both the equation, that is E1 by R1 plus E2 by R2 minus VBA will be common 1 by R1 plus 1 by R2, and I1 plus I2 is equal to I. We have already derived this by using Kirchhoff's current law. Okay. Now see, suppose I replace both the cells with a single cell of EMF E equivalent and internal resistance R equivalent. So TPD across them will be minus IR equivalent plus E equivalent. So minus IR equivalent will be E equivalent minus VBA, and I will be equal to E equivalent by R equivalent minus VBA by R equivalent. Now if we will compare this equation with this equation, so in the place of I we have I. On the place of E equivalent by R equivalent we have E1 by R1 plus E2 by R2 minus VBA minus VBA, and 1 upon R equivalent is 1 upon R1 plus 1 upon R2. So by comparing both this equation, what we'll get? We'll get E equivalent by R equivalent equal to E1 by R1 plus E2 by R2, and 1 upon R equivalent will be 1 by R1 plus 1 by R2. So these two equations are most important, remember, but remember that to calculate E equivalent we'll need R equivalent. So you have to calculate equivalent resistance first, then you have to calculate equivalent EMF. So how to do that, we'll solve one question. Suppose we have two cells, one of 4 volt and another of 8 volt. One of 4 volt has internal resistance 0.2 ohm and 8 volt also has internal resistance 0.2 ohm. Now I want to find out equivalent EMF and equivalent internal resistance. So first we'll calculate equivalent internal resistance. So 1 upon R equivalent will be 1 by R1 plus 1 by R2. Putting value of R1 to be 0.2, R2 to be 0.2. 1 upon R equivalent will be 2 upon 0.2, and R equivalent will be 0.1 ohm. Now putting this value in this equation, that is E equivalent by R equivalent equal to E1 by R1 plus E2 by R2, putting value of E1 and E2 and putting value of R equivalent, we can solve value of E equivalent. So this is how you have to find out equivalent EMF and equivalent resistance. But remember, in this case, both the EMF are taken to be positive. The reason is that the positive of one is connected to positive of second. Okay, in this question we have three cells, 10 volt, 10 volt, 10 volt. So first cell is internal resistance of 0.1 ohm, second cell is resistance of 0.2 ohm, third cell is internal resistance of 0.1 ohm. Now I have to calculate E equivalent and R equivalent. If you'll see, all the positive terminals are connected to each other, so all the EMF will take to be positive. First we will calculate R equivalent. So 1 upon R equivalent will be 1 upon 0.1 plus 1 upon 0.2 plus 1 upon 0.1. So R equivalent will be 0.2 upon 5 ohm. It's simple mathematics. Then we have to put this value in this equation, that is E equivalent by R equivalent will be equal to E1 by R1 plus E2 by R2 plus E3 by R3. Putting all the values we can calculate E equivalent. So this is how you have to find out equivalent EMF and equivalent resistance when cells are connected in parallel. Okay, now in this question if you'll see, the positive of one battery is connected to negative of another. Now R equivalent will be same, like the same way. So 1 upon R equivalent will be 1 by R1 plus 1 by R2. R1 and R2 both are 0.1. So R equivalent will be 0.1 upon 2 ohm. But while calculating E equivalent, if you are taking the top cell to be forward, then bottom will be -8 because the negative is connected to the positive. So one will be 4, one will be -8. Now you have to solve this equation to find out E equivalent and R equivalent. Okay, so now what you have to do is you have to submit an online quiz on cells in parallel depending on the lecture that we have learned today. But remember how to calculate TPD, remember how to calculate the equivalent resistance and equivalent EMF when cells are in parallel. Both are very important derivations. Okay.